Hello and welcome to the Toolkit for Traders YouTube channel where we give you the tools for trading success. And today is the 10th episode of the MQL5 Programming tutorial series. And in today's video, we're going to look at using classes to make life easy. We need to do that because the way we opened trades in the last episode only works for one particular kind of trading method, and that is hedging. So we need to make it work for netting as well, depending on what system your broker will allow. And we're going to look at how we can use classes and objects to make that opening and closing easier using inheritance. So if you like this video, do give us a like and a subscribe. It's really encouraging to me. And also leave a comment, any comment. Just say whether you like it, whether you don't like it, what you found hard, what you found easy, all that kind of good stuff helps other people to find the channel as well. So if you've enjoyed doing this tutorial series, then liking the video and commenting is a really effective way that you can make sure other people can get the most out of this series as well. So the quote for today's lesson is from Jack Ma, one of the richest men in the world at the moment, or was, I don't know currently, but here we go. Never give up. Today is hard. Tomorrow will be worse, but the day after tomorrow will be sunshine. And that reason I put this quote in is because over the next 2 or 3 episodes, we're going to do some pretty heavy stuff with the coding, and it's going to be slightly different than what we normally do in the series up to now, or indeed the MQL4 series, because we're going to have to use some pretty advanced stuff within object-oriented programming to get this to work. It's going to be difficult. This is a bit of a slog section of the series, but if you've made it this far, then I'm sure you'll get through this and you will have learned masses in terms of how to code that would apply in any other coding language that you may use that has object-oriented elements to it. And also you'll be able to, once we've written this, you don't have to do this again every time we've written an EA. This will be a sort of write once, and then you can use the code here in all of your EAs because we're going to use include files. So I just want to encourage you to plow through this episode and the next episode and the one after that. Go through it a couple of times if you need to, if you're not quite following. But just rest assured that once you've done this, we're setting ourselves up for future success because this will be the foundation for everything that we do going forward. So we're going to look at netting and hedging now, which are 2 ways of executing positions within MetaTrader. So in MQL4, you could only do hedging mode, and in hedging mode, a trader can keep both buy and sell orders open simultaneously. So you can have multiple positions in the same direction, in different directions, and each of those positions has its own ticket number and has its own stop loss and take profit. Netting is different because it combines multiple trades into one position. So with a netting system, you can only ever have one position open. If you were to open a buy and then open a sell, those two would cancel each other out. And you would have net zero. So effectively achieving the same thing as hedging, because you would be neutral to the direction of the market. If you had 2 positions open in different directions, you'd be neutral to it going up and down. But in netting, you don't incur the cost for that because you then don't have any position open. So there are some benefits to that. Netting accounts is also good for those in the USA where you have to use the first in, first out rule, or FIFO, which means orders have to be closed in chronological order, which is a bit of a nuance for those working in the US, meaning that if you put an order in, the first one you put in is the first one that's got to come out. So that is an extra complication, but netting helps with that. And as I said before, MetaTrader 4 only allowed hedging, which is why this section of the series was easier in MQL4, because we only had to look at taking ticket numbers and individual orders that we put in place. But MQL5, one of the advancements they did make was to include netting, and it is generally more profitable because You have lower costs because you generally reduce your position size by only having one position open, which means you're paying less in swap fees and commissions. You can also use that to potentially offset the spread when you enter an exit position. So netting can be really useful, although it is a little bit more complicated and difficult to imagine and understand what's happening, but generally pretty good. So the way you know whether you're in hedging or netting mode in your expert advisor. So if you go onto your MetaTrader terminal, you look at the top here, and you will see the word hedge, which shows you that you've got a hedge type system. So the type of opening that we had in the last episode would have worked for this because we were doing a hedging type system where you take ticket numbers. That's good. If you have netting, it will say there netting or net. And if you want to find out within the expert advisor rather than looking at the terminal, you can use this function, account info integer, which we've used, symbol info double, very similar functions in previous episodes. So this is going to give us an integer value of the account information, and what we want is the count margin mode, and we want to know if it's retail netting or retail hedging or mode exchange, but we're primarily in retail markets. We're going to be looking at netting and hedging. So we can use this question to find out what kind of mode we're in, and then we can use that to program our expert advisor accordingly. So let's have a little look at a practical. Let's have a little look at a practical example for how we might use hedging and netting, or how they are different. So suppose we're making a grid trading system which has a martingale in it. So every time you lose, you double the size, the lot size, so that you, in theory, you would never lose if you had infinite money, but nobody does. So eventually you will lose all your money. But let's say we want to do it anyway, and we open a buy trade here for one lot, but unfortunately our buy trade goes down, and this is in hedging mode. So we've opened one lot, it's gone down, so we're losing. So we're going to open a sell trade in our hedging, in our grid example, but unfortunately our sell trade also lost as well. So because we're using martingale, we've had to open a two lots to double the size here. Our sell trade's gone the wrong way, so we've had to open another one. We've doubled the size, we've got four lots, and our buy trade has also lost. And you see here that the number of lots we have open is currently 7. So we've not closed these trades off yet, but our number of lots is 7. So we are incurring any swap fees for having that in place. We then finally open our last sell trade, which is, hurrah, a good one. And the price does carry on going down. And we've opened 8 lots because we've had to double. And you can see how quickly this martingale system would cause a problem. So, and at this position, we have 15 lots open. So we're incurring the swap fees for 15 lots if this was running over a long period of time, which would be quite challenging. So if we switch to a netting example, and you're going to have to just bear with me on this one, we have the same situation again. We open a one lot buy trade that goes against us. So we decide that we need to be, remember, our net position needs to be 2 lots in the opposite direction. So we have to actually open 3 lots, because the only way to close this lot and have a net positive position here is to open a position that not only does it go, we want to have a sell trade for 2 lots, we also need to cancel out the buy trade in the opposite direction. So we have to add those two together to get our net position of 2. When we open the next one, we want to be in a buy position and net position of 4. However, we need to account for the fact we've got a 2 lot. We had a 2 lot sell position in, so we have to account that. So the 4 plus 2 is 6. And then finally for the sell trade, again, we want to be net 8 lots up, and we need to account for the 4 that we had in that direction, so we're going 12 lots down. So you can see that when we close the trades, we have to cancel out the position in the up direction. We don't actually close trade. It doesn't have in netting, there is no closing trades. All you do is open a position in the opposite direction. If you want to close a trade, you open it to the exact same value so that you no longer have a position there. So that's a bit of an example of the difference between hedging and netting. Hope that makes sense. So we're going to go over something different because we need to be able to handle these two differences within our expert advisor and expert advisors going forward. And what we don't want to do is write the code for opening orders every single time we go to write a new EA, because that'll become cumbersome. It's going to slow us down. It's going to mean that we're not going to be able to produce as many EAs for testing and back testing as we might want, because we're going to be doing this very slowly. And equally, if we were to try and sell or pass on our expert advisors and our customer was using a different kind of system that we're used to, say they were using netting and you're used to using hedging, that's not good, because you're going to have to rewrite the whole thing. So what we want to do is we want to have a system within our expert advisor that can handle both of those situations. And that's where we're going to go back to our car example, and we're going to look at classes and inheritance. So back to the car analogy, and suppose I've created a class, and you remember when we looked at classes before, we said they're like the blueprint for creating a car, which is the object. So we create our class car here. We've got our public variables and functions here. We've got our private variables and functions here, which can only be used within the car class, these ones. And now we've written that car. So we had this is our car. It's got various things that we can, variables that we can use. It's got functions that we can use. It's got a constructor function here. This is our car, and this is a blueprint. And we could create car objects if we wanted to. But what if we wanted to create something that was similar to a car and had lots of similarities to a car, but wasn't quite a car? So say, for instance, we want to build a caravan. It'd be pointless to rewrite the whole caravan from scratch, because we've written the car class, and actually a camper van has a lot of similarities to a car, right? It's got 4 wheels, it's got headlights, it's got an engine, it's got a throttle. There's lots of things. Now, a car doesn't have a bed, it doesn't have a cooker in it, but they do share a lot of things in common. So we want to avoid rewriting things where we've already written them, and then be able to just extend for the functionality for just the camper van. So what we can do then is we can create a camper van class here, but what we can then say is, what we want you to do, compiler, is we want you to inherit from the car class. Everything from the car class we want to be in the camper van class. So this is called inheritance. So our camper van will be a derived class from our car. So it's going to inherit all the public and protected variables and functions from the car class. Now, if you remember, in the car class, we had the private encapsulation. So if you look here, this was our car class, and this used to say private. If I go back a few slides, just so you believe me, it said private. Private means that it can only be used, the variables and functions here can only be used within the method itself. Now, private specifically means that it will not be inherited by any class that is derived from this one. So because we want things to be derived from it, we need to change in the parent car class, we need to change as protected. Protected means that these variables and functions can only be used within the class itself, but it also allows it to be inherited by any derived class like our camper van. So we change this word to protect it so that it will be inherited, and then we can go back to our campervan and we can work on that. So with our campervan class, we don't need the function, we don't need the variable speed, we don't need the our headlights on function, we don't need the gear, we don't need the change gear, because all of these are within our parent car class. So they're already, when the compiler puts this all together, it will already put it into the campervan class. So that saved us loads and loads of work in rewriting the same variables, the same functions within our campervan class. It's going to take all of that out and put it into from the car class and put it into our campervan class, which makes a lot of sense because things about speed and headlights and wheels and seat belts are all things that are common between cars and campervans. And what we can then do is we just need then our public and private encapsulation. So saying whether these variables and functions are can be used outside of the class or within it, and whether they can be inherited. And then we can have specific variables, specific functions that work for just a campervan. So we've got open awning, right? Because most cars don't have awnings, campervans do. So we've got a function to open that can be done outside of the campervan because it's in the public section. We've also got privates, which is, I suppose visually you can only see the number of embeds from internally, right? Private variables can only be seen internally within the class, and you'll see more of that when we look at our MetaEditor example. We've also got is the battery charge as a function. It's going to return a Boolean, as you can see here. And these are all specific members, specific variables and functions that apply to the campervan. Now, these won't be in the car class because we're inheriting from the car, not back to it. But the campervan will have all the functions from the car as well as these additional ones that we've done here. So if we look here, we've got we create our campervan and we call it my awesome campervan. We've got a function here called my awesome campervan dot open awning. So we're using this public open awning function here, which is from the campervan class. But we've also got the lights function here, ball lights equals my awesome campervan dot r headlines on. And that's not from here, that's from the original car class. So you can see how that inheritance works and means we don't have to rewrite our code. So before we go to MetaEditor, and we're going to only be briefly in the MetaEditor today because we're going to look at a more wholehearted and I think basically what I've decided to do is split up this episode into two because we're going to spend a lot of time in MetaEditor creating these two class functions. So we're just going to look briefly in the MetaEditor in a moment, and then we're going to have a more meaty, beefy session within it in the next episode. But before we go, just a reminder, stay in touch with the comments. We've got a Discord channel which is in the links below, and then you can also see the source files and PDFs for the lessons on the website or also in the Discord. And you can get in touch. I'm posting on Twitter, Instagram, and a lot of time on the YouTube comments as well, so go there. So let's go to the MetaEditor now and let's have a look at the different types of hedging and netting that we might see. Okay, so we're in the MetaTrader now, and as I was saying in the slides, you can see at the top here we have this hedge word here, where the demo account title is. So that's one where you can see that. And what if we want to do that programmatically? So if we open up the IDE, and I'll bring that over. So we'll just have a new one just for this, just for the sake of this one. So we'll have called account type. It's just going to be a simple EA. That is just going to, when we load it on, we're going to make a comment. So we'll have a comment and we'll say, let's have a string message, and we'll comment that message. and then in between we'll say message equals. So we can use that account info integer, which we spoke about in the slides. And if we press F1, highlight that and press F1, that'll bring up the help for that. So you can see how that can be used. Now it's the enum account info integer to get the difference. So we wanted the, let's have a look. We wanted the margin calculation mode here. Okay, so enum account margin mode. So we'll put that in here. Account margin mode. And we'll get 2 messages back. So we can just have a, if we just put it like that for now, and that's going to return a long. So that's just going to return a number. So what we might actually want to do is first, before that actually, we'll just clear it when we remove the EA. So we're not left with that. And what we might do then is we'll say if, so let's also have long account type equals this. We'll just take this out here. So we'll retrieve that. We will then, depending on what we get, so if account type is equal to account, let's go to the help documents, account margin mode retail, account underscore margin underscore mode, retail hedging. If it's that, we'll put a message equal to hedging account, and we'll spell that correctly. And else if, again, account type is equal to account underscore margin mode netting, we will say that message is equal to netting account. And you'll see I've not put curly brackets for here. I could have written this like this. But if it's just one line, you can get away with it. You could even do it like this if you wanted to, which you might say is a bit cleaner and easier, but we'll put it like that. That only works for when there's one line following the if statement. So we'll have that surface there, and then we could also have an else statement. So we can say if it doesn't qualify on those, unknown, let's say. And we'll compile that. Expression has no effect. Message equals. Okay, so we've generated our code, we've got an EA. So now we can go back into MetaTrader. We can look for our account type EA, drag that on, and it brings up this pop-up. We'll press OK, and you can see there it says hedging account. So let's see, can I actually open a MetaQuotes demo hedging account? Next. Account type Forex hedged. Can't seem to open a netted one. Never mind, you'll have to take my word for it that will work. So, we've just created a simple thing where we can programmatically, in the IDE, we can programmatically understand whether we've got a hedging account or a netting account, and then we can use that to select the type of function that we want to use or the type of account that we're going to use that in. I'm not going to go into going back into our previous lesson and rebuilding it all into here. because it would take too long in one lesson. So we're going to effectively split this lesson into two, and we are going to spend most of the next lesson in the MetaEditor constructing the classes to do our trades. So hopefully that made sense, and I'll see you for the next video when we will build out the classes for trading in hedging and netting mode. So in the next video, we're going to spend a lot longer in the MetaEditor fleshing out these classes we're going to use for netting and hedging modes. We'll be writing each class, which will inherit from a parent class, and we'll be getting the EA to choose automatically between them. So if you have any questions or any comments for this one, I appreciate this one was a bit more abstract than usual. Do drop a comment in the section below and I'll try to answer your question as best I can. Alternatively, reach out on Discord or any of the social medias that I have. And that's all for this lesson. I hope you've enjoyed it. I hope you got through it, and I'll see you in the next one for some more MQL5 coding.